Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 5 of lesson number 1, Matter in Our Surroundings. So might be in this part or not in this part, then in the next part we will be ending up with this lesson Matter in Our Surrounding. Because if you all remember, in the last class we have discussed about the properties of solid, properties of liquid, and properties of gases, right? So we have all studied the properties of three states of matter, which are found to be very important along with an activity. And if possible, like I've told you, wherever possible, make sure you are doing the activity if the materials are available with you. But if the materials are not available, I can understand it, but but if all the materials are easily available, please make sure you're not skipping that activity or performing it, and knowing the inference to it, knowing the observation, knowing explanation, everything about it. Okay, so now before I start with this part, that is part 5, I want you all to please revise whatever you have written in your book, because the notes that you are making on your own, when I tell you to write this point, that point, whatever notes you are making, whatever activity description that you're giving, you might be giving explanation, observation and inference for your activity, right? So make sure you're knowing it as well. Please go through it once, read that once, everyone. I hope everyone is going through whatever you have written in your book. Now, I'm going to show you the slides one by one. Please make sure each and every one of you are going through it. So we have discussed about matter, what exactly matter is. How can you define matter? It is anything which occupies space and it has mass, right? That is matter. And how can we classify matter? So we know that Indian philosophers, they have classified matter in the form of, like, they stated that matter can exist in five basic elements, that can be air, earth, fire, sky, water, right? And we know this as pancha tattva. What do we know it as? Pancha tattva, right? So on the basis of, like, he have classified matter in two different aspects. First is on the basis of physical state of matter. We can classify, you can say, matter on the basis of physical state. We can classify it as solid, liquid and gas. And on the basis of chemical composition, we can classify matter as pure substance and mixtures. Okay, and this pure substance that we can have, we can further classify that as elements or compounds, and mixtures can either be homogeneous or it can be heterogeneous. So this is what you should be knowing. Okay, so I just want you all to please go through this slide once. After this, like, we discussed on the physical nature of matter with respect to activity 1.1, right? So I want you all to please go through this slide as well. After this, we discussed on how small are the particles of matter, right? So I just want you all to please go through it once. After this, we discussed on like characteristics of particles of matter, and I want you all to please go through it properly. See, here we have discussed how like particles are been arranged in solid, liquid, and gas, right? So make sure you know it. After this, we had discussed this activity 1.2.1 with respect to like with it. You might have written the observation, inference, and you can say explanation as well. So I want you all to please go through it. I hope everyone is going through this. After this, we have like particles of matter are continuously moving, right? So like this is how the figure is, and like this is how you can say a proper particles of matter are there together. So in solids the particles are going to be compactly arranged. In liquid they will be moving freely, but not as that in like gas, because gas may, you will feel like that they don't have any attachment with each other, so they will move freely anywhere. Okay. After this, particles of matter, like how they move continuously, we discussed on that same thing but with an activity, right? Because like whenever we burn an incense stick and you put in one of the corner, you will see that the smell of the incense stick spreads like you can say in every corner of the room. So we can say that particles of matter They move continuously by performing this activity. But like you can also perform it using a perfume, because if perfume has been spread in one corner of or in one of the room, you will get that smell in all the rooms, right? So that is how like you can come to know and you can conclude it. Then we discussed on this activity 1.4. So I just want you all to please go through it. After this, we discussed on this activity 1.5. I want each one of you to please go through this slide once. So here we just added some crystals of potassium permanganate, but as I told you, like because you don't have it, we can try it with something else which is easily available at home, but you need to perform the activity somehow. Okay. Then we discussed on like that particles of matter attract each other, and that is like we have discussed through an activity, that is activity 1.6, right? After this we had this activity 1.7, so I want you all to please go through this as well. After this we discussed on this activity 1.8 in the last class, if you all remember it. Then after this activity 1.8, we discussed on the three different types of like three different states of matter, that is solid, liquid and gas, and we have studied like the properties of solid in detail, right? So here we have the six different properties along with the figure for solid, liquid and gases which have been shown. Here they have like tried to make us understand how exactly the particles are arranged in solid, liquid and gas. Okay, so I want you all to please go through it once. I hope everyone is going through it. After this, like the properties of solids, like when you go through this activity, you'll find out that this activity is going to you can say satisfy all the properties of solids. So I want you all to please go through it once. After this, we discussed on properties of liquids. So I want you all to please go through it once. After this properties of liquid, we discussed on this activity 1.10. So I just want you all to go through it as well properly. Then we discussed on the properties of gas. So please go through these properties once, everyone. Then we discussed on this activity. So I just want you all to please go through it. So now like we have to discuss more about this properties of gases, if you all remember, right? So wait, see. We have observed that gases are highly compressible as compared to solids and liquids, right? We have already studied that because these gases are highly compressible, because of which we can like store them inside a cylinder as well, right? So the liquefied petroleum gas, the LPG cylinder that we get in our home for cooking, or the oxygen which has been supplied to hospitals and cylinders, they are all compressed gas. The gas has been compressed because we know gases are compressible, right? So compressed natural gas, which we call it as CNG, it is the cleaner fuel that we use, right? So this is used as fuel nowadays in vehicles, and due to its higher compressibility, large volume of gas can be compressed into a small cylinder and transported easily. Now, because CNG, LPG, they are highly compressible gases. So, because of having this high compressibility, it becomes easier like to have large volume of gases inserted or compressed into a smaller cylinders, and we can transport them easily. So we come to know of what has been cooked in the kitchen without even entering there, right? If your mama is cooking something special for you, you come to know that like by the smell when she cooks. So how does that reaches your nostril? We know that the particles of the aroma of the food, it mixes with the particles of air, right? If she's using some ghee or something to make some to like make your favorite dish, what will happen? The particles of that will like get mixed with the particles of the air, and that is how, if you remember the activity of incense stick, the same thing happens with this as well. Okay, so it is going to reach us and even farther away. So the smell of hot cooked food reaches us in seconds, And compare this with the rate of diffusion of solids and liquids. So diffusion of solids and liquids are very less as compared to gas, because through gas it is like very easy to, you can say, it is very easy to diffuse the air, diffuse the, you can say, aroma in the sky, in the air around us. So in gaseous state, the particles move about randomly at a very high speed. Because of this random movement, the particles will heat each other and also the walls of the container. So in that case, the pressure exerted by the gas is because of this force exerted by gas particle per unit area on the walls of container. Okay. So I hope every one of you is going through it. Now see, here we have the particles, how they are compactly arranged in solid. In liquids, like the particles have like some of the spaces, like there's small intermolecular space present in liquid, but in gases, the intermolecular space that exists is very high. Okay, so this is how, like, we can say this is the schematic representation of, you can say, the particles, how exactly they are been arranged in solid, liquid and gas. Okay. Then we have the next topic as, like, can matter change its state? Now what do you all think? Can matter change its state? Okay, so see, we all know from our observation that water can exist in three states of matter, right? How many states of matter? Three states of matter, right? So, like as in, if it is an ice form, it will be a solid. The liquid is the most common water that we have, and gaseous form can be the water vapor. So it means water is something that can exist in all the three states, right? After that, now what happens inside the matter during this change of state? What do you think, what will happen inside the matter if the state is changing from like ice, from solid to liquid, liquid to gas? Do you think that the particles of matter will they be responsible for changing the states? And how does this change of state takes place? So we need answer to all these questions, right? For that we will be like studying the effect of change of temperature and effect of change of pressure in detail, right? But before that, you can take a note on like how water can exist in all the three states. So see, now we will be discussing on effect of change of temperature. Okay, now the first figure that you have, in that the ice is getting converted to water, and the second figure that you can see, in that case the water is getting converted to water vapor. Okay, now see, take about 150 grams of ice in a beaker and suspend a lab thermometer so that its bulb is in contact with the ice. What will you do? You have to suspend uh, a lab thermometer so that the bulb which is in contact with it is in contact with the ice. Okay, so see, in the first figure, as you can see, you have to put ice in the beaker and a thermometer should be attached over here. You have to check like what will be the temperature in the thermometer when till the ice melts. Okay, and in the second one, you have to like heat the water and the water will get converted to water vapor, right? There also you need to have a thermometer placed inside it because you're going to you're going to check the temperature over here. So see, start heating the beaker on a low flame. Note the temperature when the ice starts melting and record your observation. Sorry, note the temperature when all the ice have converted to water. So you have to note it twice. Once when the ice starts melting and second time when the ice has converted into water. Okay, we so in both the cases we need to note the temperature. Now record your observation for this conversion of solid to liquid state. Now we have to make sure that we are observing how the conversion of solid, that is ice, to liquid, that is water, is taking place. And now put a glass rod in the beaker and heat while stirring till the water starts boiling. Getting it? After this, keep a careful eye on the thermometer reading till most of the water has vaporized and record your observation for conversion of water in the liquid state to the gaseous state. Now you have to do the same thing that you have done for for conversion of solid to liquid. It's just that now you will be like observing or noting down the things when there is a conversion from liquid to gaseous state. Okay. Now on increasing the temperature of solid, the kinetic energy of the particle will increase. So when I'm increasing the temperature of solid, kinetic energy will increase, and because kinetic energy is increasing, it will start vibrating with greater speed. So the energy which has been supplied by the heat overcomes the force of attraction between the particle. What will happen? Energy supplied by heat overcomes the force of attraction between the particle, and here the particle leave their fixed position and start moving more freely. What will happen? The particle will leave their fixed position and they will start moving freely. So they will reach a state when the solid will melt, and the solid will, like after melting, the solid will get converted to liquid. So the minimum temperature at which a solid melts to become a liquid is called, like at the atmospheric pressure, we call it as melting point. Okay, so here we have the definition of melting point: the minimum temperature at which solid melts to become liquid at atmospheric pressure, we call it as its melting point. Okay, and the melting point of solid is an indication of the strength that it has between the particles. That is also very important. Okay, then the melting point of ice is 273.15 Kelvin, and the process of melting, that is change of solid state into liquid state, is known as fusion. So when the solid state is changing to liquid state, we call that process as fusion. Okay, and when a solid melts, the temperature will remain the same in that case. What will happen? The temperature will remain the same. So where does the heat energy go in that case? So when we are performing the experiment of melting, the temperature will not change after melting point is reached till the ice is melting, and that is why we have to continue heating the beaker. Okay, it means we have to continue supplying the heat, and this heat is going to get changed by overcoming the force of attraction between the particle. Okay, so I just want you all to please write the definition of melting point and the melting point of ice, that is with. I hope everyone is taking a note of it. See, after this, as you know, like as and when we are heating it, the force of attraction, like they are going to overcome between the particle, right? So as this heat energy is absorbed by the ice without showing any rise in temperature, we consider that it is getting hidden into the content of the beaker, and we know that as latent heat. Latent heat is something, you can call it as like hidden heat. Okay, so that is latent heat, and the word latent means hidden. So the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Now this definition is important. What has been said over here? Amount of heat energy required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So when it comes to particles in water at 0 degrees Celsius, they will have more energy as compared to particles in ice at same temperature. So when we are supplying heat energy to water, the particles in that water molecule will start moving very fast, and at a certain temperature you will come to know, like a point will be reached when the particles will have enough energy to break free from the force of attraction of each other. Getting it? So when this is happening, the temperature of the liquid will start changing. The liquid will start changing to gas in that case, and the temperature at which liquid starts boiling at the atmospheric pressure, we know that temperature as its boiling point. Okay, and always remember that boiling is a bulk phenomenon where the particles from bulk of the liquid, they're going to gain some energy and they're going to get converted into vapor state. So for this, see, for water, this temperature is 373 Kelvin, that is 100 degrees Celsius is equal to 273 plus 100. So it becomes 373 Kelvin. Okay. So now we have the next thing as latent heat of vaporization. So we have to do the same way how we have defined latent heat of fusion. But here particles in steam, that is water vapor, at 373 Kelvin have more energy than water at the same temperature, because when we are heating them, the particles in steam, they will absorb some extra energy and they are going to form heat of vaporization. So see, solid state, when you heat it, it gets converted to liquid state. Liquid state, when you heat it, it gets converted to gaseous state. Gaseous state, when cooled, gets converted to liquid state, and liquid state when cooled gets converted to solid state again. So I want you all to write some of the important definitions, some of the important boiling points, melting points which have been given from the screen. And after that, like after doing that, I want you all to even like write about this changes from solid to liquid, liquid to gas, how exactly it takes place. I hope everyone has written this in your book. Right now, in the next class we will discuss about sublimation in detail, and sublimation will be with respect to ammonium chloride. Okay, so we'll do that in the next class. Then we will discuss about effect of change of pressure in detail, and then this is the interconversion of the three states of matter which have been shown, which we will be doing in the next class itself. Okay, and then we have evaporation process to discuss in detail, like what exactly evaporation is. We will be discussing that in detail as well. Okay, then after evaporation we have factors affecting evaporation. We will even discuss that in detail. And after this, studying about factors affecting evaporation, we will be doing that through an activity again. And after that we will be discussing on the rate of evaporation, like how exactly the rate of the evaporation increases, because that also matters a lot, right? So we'll do that as well. And after studying how exactly the rate of evaporation increases, we will discuss on how do evaporation cause cooling, cause that is also very important. Okay, so we will be studying about high energy evaporation, medium energy, and there are many different things which you are going to learn. And as we have already studied before, that apart from the three states of matter, that is solid, liquid, and gas, we have other two states of matter as well, that is plasma and Bose-Einstein condensate. These are the other two states of matter as well. So we will be discussing on them as well in detail. And then we have summary discussion to do for the whole lesson, matter in our surrounding. Okay, so this is going to help us in knowing whether you have understood all the concepts or not. So we'll be doing the summary discussion, where we have after doing the summary discussion we have some of the quantities along with the unit and the symbol which are been given. So we will be doing this as well. Okay, the quantity, unit, and the symbols of few of the measurable quantities which have been given. So I just want you all to please go through this, because after studying this we will be discussing on some of the exercise questions as well. Okay, so I'm going to show you all the questions one by one. I want you to go through them all. I hope everyone is going through it. So this is how we will be like ending up with the lesson by discussing on the exercise questions. Okay, and I hope like whatever we discussed today you're very much clear with it. Now next part can be the last part for the lesson, so make sure you all are revising whatever we have studied so far in the lesson matter in our surrounding. Okay, now whatever has been left I will be continuing that in the next class. Thank you everyone.